Welcome to The Explainer. Today, we're diving into something really special. We're going to explore a fascinating geometric framework that actually attempts what physicists have been dreaming about for a century, literally unifying gravity and quantum mechanics. We're looking at the work of Dr. Ahmed Rihan, who suggests that if we just completely rethink our most basic visual models of space, we might actually find a single unified structure that connects the vast cosmos all the way down to the tiniest building blocks of matter.
So think about this for a second. What if the vast cosmic web of the universe and the microscopic structure of an atom share the exact same geometric shape? I mean, it's a totally mind-bending question, right? But this is the cold open premise of Dr. Rihan's theoretical framework. It points to this incredible scale-hopping reality, where the exact same rules that organize massive galaxy clusters are the ones organizing an atomic nucleus, all driven by pure three-dimensional geometry.
Section 1, Beyond the Rubber Sheet. Let's look at this 3D upgrade. For decades, the absolute go-to pedagogical analogy for Einstein's general relativity has been that classic image, a heavy bowling ball sitting on a 2D rubber sheet creating a downward dip. And sure, it's a great teaching tool, but it's, fundamentally only two-dimensional. Rihan's framework actually upgrades this to a fully three-dimensional model, because gravity acts equally in every radial direction, right? So the space around a massive object doesn't just form a flat little dip, it forms a 3D spherical packing of potential wells.
And that brings us right to the core of the Rihan nested bubble cosmos. The idea is that every single massive body is enclosed by a spherical bubble, and the size of that bubble is set by the depth of its gravitational curvature. Now, because the universe is filled with masses of all different sizes, these bubbles pack together almost exactly like cosmic Russian nesting dolls. A star has its bubble, which sits inside the much larger bubble of its host galaxy, which nests inside a massive cluster-scale bubble. It's entirely consistent with general relativity. It just brilliantly restores the three-dimensional symmetry that our old 2D drawings always suppress.
Moving right along, Section 2, Cosmic Voids and Filaments. Now, standard cosmology relies heavily on some very successful yet completely unproven exotic fluids. Things like dark matter and dark energy, along with cosmic inflation, just to explain the universe's structure. But in the Rihan theory, the cosmic web, with its dense filaments of galaxies and those massive, sprawling empty voids, actually emerges purely from sphere-packing geometry, meaning these huge cosmic voids are literally nothing more than the inevitable geometric gaps that just naturally appear when you pack countless bubbles together. It elegantly replaces a phenomenological patchwork with just one single topological principle.
To put a precise number on that geometry, we're talking about 26%. Basically, if you pack similar-sized spheres together as densely as possible, what's called a face-centered cubic packing, the natural geometric voids left in between them will always occupy about 26% of the total space. And this effortlessly explains the existence of massive cosmic structures, like the Booty's void, or even the local bubble surrounding our own solar system. You literally don't need extra made-up physics to carve out these empty spaces. They're just the natural interstices between packed gravitational balls.
Section 3, Geometry of the Atom. Let's look at the microscopic scales.
All right, so we are now jumping down 20 orders of magnitude. And this is where the scale-hopping premise really gets wild. The framework essentially claims that the universe uses the exact identical geometry for a tiny atom as it does for a giant galaxy supercluster.
Think back to high school physics and Ernest Rutherford's famous gold foil experiment. That was the one that proved atoms are mostly empty space, right? Well, the Rihan framework actually gives us a visual spatial reason for this. In a 3D bubble model, when alpha particles are fired at an atom, the vast majority of them simply travel straight through those exact same geometric gaps we just talked about on the cosmic scale. Sharp deflections only happen when a particle directly strikes a compact nuclear bubble. It's a beautifully intuitive geometric alternative to the standard abstract math. And it goes even further, directly connecting to quantum mechanics. We all learn about Bohr's atomic model, where electrons jump between discrete energy levels. But have you ever wondered why they are discrete? This framework actually proposes a literal spatial answer. An electron occupies a stable, filamentary orbit that's wound right around the nuclear bubble. So when it gains or loses energy, it isn't making some weird, abstract mathematical leap. It is literally sliding from one physical, concentric filamentary shell to the next. So abstract energy jumps actually become literal geographic transitions.
Section 4, Spiraling Photons and Energy Conservation.
On that classic 2D rubber sheet we mentioned earlier, a photon looks like it's traveling in a straight line that dips and curves, and it appears to lose or gain energy to gravitational redshift. But in the 3D nested bubble picture, things look beautifully different. The framework posits that a photon travels along a helical or spiral trajectory tightly wound around the filamentary ridges where neighboring bubbles intersect. So instead of losing energy, the photon travels in a purely energy-conserving spiral path. There's a quote from the source material that really hits the nail on the head here. It says, "The spiral motion realizes the equivalence of mass and energy, E equals mc squared, as two faces of a single conserved coin. This helical path length exactly compensates for the differences in gravitational potential. Because the photon is spiraling, its local energy remains completely constant when measured by a freely falling observer." Basically, the framework suggests that this spiral motion physically visualizes Einstein's famous E equaled mc squared. Mass and energy become geometrically transparent as those two faces of a single conserved coin, just twisting right through the filamentary scaffolding of space. Section 5, the Swiss cheese mathematics. Let's talk exact solutions. So, to prove this isn't just a pretty analogy, the source material turns to something wonderfully named Swiss cheese cosmology. First introduced by Albert Einstein and Ernst Strauss way back in 1945, this exact mathematical model embeds localized spherical mass regions, or holes, inside a smooth, expanding universe. It perfectly illustrates how empty voids and central compact masses can mathematically coexist without breaking a single one of Einstein's original equations. To really demystify how this mathematical insertion works, you can think of it almost like a cosmic recipe. Step 1, you start with the standard metric for a smooth, expanding universe. Step 2, you mathematically cut out, or excise, a perfectly spherical ball of space. Third, you insert an interior metric, like a black hole or a star, whose mass exactly matches the cheese you just removed. And finally, step 4, you carefully match the boundaries so the math flows seamlessly from the inside to the outside. This classic four-step process mathematically embeds a nested bubble, giving a completely rigorous foundation for Rihann's geometry. Building on all that, the framework outlines some very specific mathematical derivations to construct these multi-bubble universes. We're talking weak field metrics superimposing Newtonian potentials, thin shell matching for much stronger gravitational fields, all the way up to complex nested metrics for modeling stars inside galaxies, inside clusters. Now, while some of these are approximations, this whole toolkit proves a really vital point. The concrete mathematical framework within general relativity absolutely exists to fully support this nested bubble universe. Section 6, Unifying Physics' Greatest Divide, Bridging Relativity and Quantum. Okay, so let's recap the absolutely massive takeaways from Rihann nested bubble cosmos. First off, gravity is reframed entirely as 3D sphere packing geometry. And because of this, cosmic voids and filaments just emerge naturally, without necessarily needing any of those exotic dark fluids. Astoundingly, atomic structure inherits this exact identical geometry, which gives us a physical, spatial reason for nuclear transparency and discrete electron orbits. Energy conservation? Visualized perfectly by spiraling photons. And honestly, perhaps most importantly for the pure elegance of the theory, it requires zero modifications to the Einstein-Hilbert action and totally zero hidden string theory dimensions. It's just the 4 dimensions of spacetime we already know, plus a helical energy path. Which of course leaves us with this final, absolutely vital question. Will this incredibly elegant unification actually survive rigorous observational scrutiny? Look, the math is beautiful and the geometry is incredibly intuitive, but physics demands hard proof. In the near future, high-resolution space surveys like Euclid and ground-based telescopes like the LSST are going to map the cosmic web and its voids with unprecedented detail. And ultimately, those real-world observations will be what tests if the geometric claims of the Rihonn framework hold true in reality, or if they just remain a mathematically beautiful yet hypothetical way of looking at our universe.